Right, Year 12, thank you for letting me know that these are the questions you found tricky, so I'm going to just go through it very quickly. So for part A, I'm going to do very quickly, you set x equals minus 2 to show that it's a factor. You just need to show that it equals 0 to prove it is a factor. So substitute minus 2 into the formula, and then of course you will get that answer of 0. Thus x plus 2 is a factor. That's part A. That should be a blank mark. Part B will show that it could be written in this form. We know x plus 2 is a factor, so we can use a bit of algebraic division. We're finding the missing numbers, complete as you have learnt. So we know x plus 2, 4x squared minus 20x plus 25 is a factor. We've got a squared here, so we know this is the repeated root, so this could be factorised. It's a repeated root, like you can see, so we know that is x plus 2, 2x minus 5 squared if you factorise. So for part C, so that g of x is less than or equal to 0, and it says use your answer to part B, which is here. This is our answer that we have. We set it to less than or equal to 0. Now you can see the graph that it equals 0 at 2.5 and it's less than 0 to the left of this graph. So your two solutions should be x equals 2.5 and x is less when x is less than minus 2 going this way. Part 2 is understanding and application of graph transformations. Now inside the bracket we solve for x and we do the opposite, so that must mean all the x values are halved, which means essentially you would substitute 2x into your equation here to get a bit more understanding. So 2x swaps for the x above here because you can see what g of x is, and essentially if you solve these both you'll get the answer, but it's quite easy just to understand that you just half your x values, which would make sense. You'll get x equals minus 1 here. You know, it's a transformation of a half x, or half times your x coordinate. So for gx equals 0, that's our original at the start. We've got x equals minus 2, and we see that was our x here. Now if we make it 2x, you can see to solve for this you would have to half your x value to get 1, well minus 1 to be exact, and your value is x equals 2.5 here. So you half both of them, so you're halving these two coordinates, these would be your answers, and that is quite easily done. Right, we're going to start off with a binomial expansion. We know we start off with this is your A, that's your B. That's what the pattern will look like. We can use the choose function to work that out, substitute our A and B terms in. This gives us our coefficients to start off with. That is 9, 0, so that coefficient is 1 anyway. And you just continue it on, but it only asks for the first 3 terms. This is our first 3 terms. Just substitute everything in correctly to get your coefficients, and make sure your negative signs are correct, hence you'll get a minus here. Minus x squared will turn positive, so that will be positive. Now that's done, and that will get you 4 out of 4 marks up to here. Now look at this next bit. This is generally the part that students get wrong, but all you need to do here is match coefficients. This is our original question from part A. Now in part B, it's asking us what will change if this is expanded by this, and this time our coefficients are 128 and 36x. That's key. So you just need to compare with part A and match the coefficients. So in part A, the coefficient for the first term is 512, has to match 128. So the first term in question B, the coefficient is 128 and it has to match with 512. Now if you think about it, our first term is going to be given by A times 2 to the 9. Or imagine this bracket multiplied by this, our first term is going to be a times 512. That's why we get a times 2 to the 9, which is essentially here, or a times 512, that becomes 512. We're matching coefficients of 512a, because that's going to be our a times 512 equals 128. We can solve to get a equals a quarter. Now for the second part B, it's the coefficient of x, which we know is 36. So 36, we have to look, if you imagine our a plus bx multiplied by these three terms, we've got a times 144x is going to give us a coefficient of x, hence I've rooted minus 144a here, and our bx times this term is going to give us 512bx. We don't need to do this one because that will give us 144bx squared, and that's where I've got no need for other terms. There's no need for x squared and above terms. So imagine we've got a plus bx by our 5a expansion, which is that. Those are the only two we're interested in. You get 512a plus 144ax plus 512bx. Okay, and we didn't need to do the last one because that gives us x squared. Although if it asked us to compare x squared, we may need to do that. So look at that, 144a plus 512b has to equal 36, that coefficient. So from there we just solve. We know a from part 1, so we substitute that in and just solve as normal to get 9 over 64, and that is done. Right, here we go, we're going to explain this question. Part A, obviously set x equals 4, make it equal 0. Part B, show that it has two distinct roots. Well, we just factorise that using algebraic long division to find the other factors. But the question was how to do 14c in class and 14d. So if you look at the difference between both, is minus 2, because you can see 48 and 46, I've highlighted it. Those two equations are exactly the same, there's just a difference of minus 2 on the constant. So we know that is a transformation of minus 2. Alright, can you see the difference? It's that those are our two functions, and then if we were to write minus 2 here, that actually makes this. So that is our transformation. The minus 2 is outside the bracket, which affects the y. So this means the whole graph will move down two coordinates, so each y coordinate will move down 2. So that's a recap. This transformation of y coordinates all minusing 2. So you can see now it will all have 1, 2 and 3 roots. That's the answer. So part D, you've got fx plus k inside the bracket. You know that only affects the x-axis or x coordinates, and it's inside the bracket, so it's the opposite of inside. So we're looking at our original equation here, and we're saying when does it pass through this origin here. So how can the graph translate so if x equals 0 as a root? So this graph can go this way all the way here, and this graph can go to the right to get this point over here. So that would be, the first one would be x plus 4, because look, that's moving to the left 4, which is minus 4. We do the opposite, so that's x plus 4. So k could be 4 to make it x plus 4, and that would shift this all the way to the left. Okay, because that's x minus 4, that's it. Now our next root is minus 3 over 2, so it needs to move to the right, minus 3 over 2, but we do the inverse. Alright, so that means it must be minus 3 over 2 to make it plus 3 over 2, which means move right as a graph transformation. So yeah, that must mean k equals minus 3 over 2 based on this transformation, and hopefully you can see that will make sense. This whole graph will move to the right, like so. Or if I was to draw that for you, that would look like something like this.